which is used by most of the researcher. So I'm going to discuss today that in what case you can apply ANOVA, or in what case you can go for the chi-square. So if you have the basic knowledge about the uh, statistics, then only you will be able to choose the appropriate statistical test for your research. Otherwise, what will happen, most of the students are doing a excellent work in their laboratory. They are doing a very good work in the hospitals, and when they will publish their paper, or when they will going to proceed with their master's thesis or PhD thesis, there will be error while choosing the statistical test. So because of a small mistake, that a appropriate tool was not chosen by the researcher, or appropriate statistical test was not chosen by the person, can lead to rejection of the paper, or even it is going to decrease the impact of your study. So what I used to recommend to my student, that divide your result part into two different sections. The first will be considered as a descriptive statistics, and second will be considered as a analytical statistics. In description or descriptive statistics, the main aim is to summarize the variable. For example, uh, if you are working in pharmacology, then what type of animal you are taking, what will be the weight of the animal, what will be the common age of the animal, either in terms of month or either in terms of days. So all the demographic profiles of the animal or the human beings, or either it's your formulation, which is going to explain your study, the variable which you have taken for your study, all these things should come in the descriptive statistics. So once you will describe everything about your study, which includes mainly definitions as well as the criteria, that what will be the independent variable of your study and what will be the dependent variable. So once I told that independent variable and dependent variable, so you don't have to be confused. Independent variable means IV, and dependent variable means DV. For example, I have given a code to you that A is causing B. So it means A will be considered as independent variable and B will be considered as a dependent variable. And sometimes this dependent variable or B will be considered as a outcome variable. That means whenever we are conducting a research, we were trying to find out the correlation. That means what is the correlation of A with B, and what is the correlation of independent variable with the dependent variable. Directly you cannot proceed with only one type of variable in your study. So if you are giving a data of independent variable in your study, that will be represented in terms of percentage or in terms of numbers only. Otherwise, whenever you want to build a relationship between two variables, that how smoking is responsible for causing a cancer, so both variable should be added in a statistical tool. That means you require a statistical test in which one variable will act as a independent variable and second variable will act as a dependent variable. So you should have an idea that which variable is independent in your study and which variable is dependent in your study. For example, if you're working in pharmacology, then most of the animals demographic profiles, for example, age, weight, gender, then what dose you are giving, all will be considered as independent variable. And after that, the parameter which you are going to evaluate, that what is the heart rate, what is the systolic blood pressure, what is the diastolic blood pressure, what is the death time, or any sort of readings which you have got it after performing the experiment, that will be considered as a dependent variable. So whenever you are proceeding with your experiment or your research, make a list that these are my independent variable and these are my dependent variable, and you can make some sort of models. That means uh, one model can be, for example, you are going to compare BMI with fasting blood sugar. In second model, you are going to compare BMI with diastolic blood pressure, like this. So with the same variable, you can build multiple models. Clear? So whenever you will have an idea about independent variable and dependent variable, you can proceed with your research. So as I have discussed, that writing of results will be either descriptive or either analytical. So a good thesis or good research paper will have a combination of both. Once you will describe all the variable in terms of independent and dependent, then you can go for the analytical statistics. So as you will begin with the analytical statistics, the main concern is which test. So this I'm going to take today in the further slides, and you can see that these are the examples of independent variable which we can take for our study, like age, gender, race, education, income level, all the parameters or all the variable which is going to represent your population, that will be considered as a independent variable. For example, you are making a formulation. So different concentration of the drug parameter which you are going to evaluate for the efficacy, that will be considered as a dependent variable. Clear? So once you will have an idea that these are my independent variable and these are my independent variable, then second point is that what is the type. That means if I am saying that you want to build a relationship of A with B, that A is causing B. So smoking or type of smoking material. If I'm talking about number of smoking, then we can take numerical data like 5 cigarettes in a day, 10, 15, 20. So that will be considered as a numerical data. And if I want to categorize smoking as a variable, then what type of smoking material, where we have options to choose. So that type of data will be considered as a categorical data. And based upon type, we have to choose the measurement of central tendency. Now, what is these measurement of central tendency? It means that mean, median, mode, standard deviations, interquartile range, that by which mean you are going to represent your data. Most commonly used are mean and the median. That means if you want to represent your data which are given in terms of number, that means numerical data, you are going to describe your result in terms of mean and standard deviation, or the alternative is median and interquartile range. But for categorical data, obviously you cannot represent your result in terms of me. What if that author has represented his of mean and standard deviation? So you will also follow the same measurement unit. Might be that authors is eligible to write the mean. and you're working in a laboratory, and
Hello, Amit sir. Hello, hello, Amit sir. You are not audible to us. Mari sir.
Yes, madam. I think some technique, you can say, network issue is there at the site of Sir Amit sir.
Okay, you are also not audible with sir now.
Yes, yes. He's not audible.
Okay, okay, okay. I will call to him.
You can call him.
Yes, sir. Yes.
hello.
Yes, sir. You are
Yeah,
audible
so
now.
yeah, okay, thank you, thank you. Yeah, I was not knowing that at what point I was disconnected. So let me share the presentation. Just wait. A presentation is visible, right?
Yeah, yeah, visible, sir.
Yeah. So I was discussing that by taking an example that A is causing B, how we can choose the appropriate statistical test as well as the appropriate measurement of central tendency. So what we have to do, for example, you are working in a laboratory, and whenever you will perform an experiment, you are going to end up with a some sort of data in your hand. Either you're working in a hospital or either you're working in a laboratory. Finally, you're going to end up with a data. So that data are classified into two different types. One we used to call as a numerical data, and secondly we used to call as a categorical data. Clear? For categorical data, we don't have to bother that much. directly we can represent our result in terms of numbers or count. Number, count, and frequency, all these terms are the same. So first option will be the number, count, or frequency. Second option is percentage, and third option is the ratio. Ratio will be used whenever you have two category or three category. If more than three category, so will not recommend to go for ratio. You can directly use the percentage. For example, you want to write that what is the percentage of male and what is the percentage of female, or what is the percentage of drugs whenever you have multiple drugs. Clear? So percentage can be used as a tool for the categorical data. But if your data is numerical, for example, either it is a age of the animal, weight of the animal, or either what dose you have given, dose of the animal written in terms of number, then you have to identify that either that numerical data is normal or not normal. In statistics, we can find out with the help of the test called test for normality distribution. That means we have to identify that numerical data what we have got it after doing an experimentation, that is normal or not normal. Here normal means you have got a bell-shaped curve. For example, you have a age of 25 animals. For example, one animal is having a age of 4 week, and a second animal is having a age of 4 weeks 3 days, like this. So you are going to enter the age of all the animals in a Excel sheet, in a column, and then you are going to plot a graph. And if you have got a exact bell-shaped curve, what it means, it means majority of the animal which you have taken for your study having a age around 4 weeks, but some are having a age more than 4, and some animals are there having a age less than 4, but in majority 4 weeks will be given at a center. So if you are getting a bell-shaped curve, so it will be considered as a normal data. And if you didn't get bell-shaped curve, for example, you have got a curve like this, or you have got a curve like this, then it will be considered as a skewness, and we used to call that data is not normal. This will be considered as a positive skewness, and this will be considered as a negative skewness. So whenever we have a skewness in our data, it means we are not eligible to quote our results in terms of mean and standard deviation. So what the rule of stat says, that for normal data, we have to write our results in terms of mean and standard deviation. And whenever our data is not normal and we have got a skewness in our data, we have to represent our result in terms of median and interquartile range. Now, IQR is the subsequent of standard deviation only. Like always, we are writing a standard deviation along with mean. In the same way, we are writing a IQR, that interquartile range, along with the median. Clear? So from today, if you are referring any research paper or review paper on the internet, and you think that a particular author has represented his or her results in terms of mean and standard deviation, so you can assume that that person's data was normal. And if any author has represented his or her results in terms of median and interquartile range, you can assume that the person's data was not normally distributed. So why test for the normality distribution is that much important, and why I'm giving that much emphasis on this? Because after finding out either your data is normal or not normal, then only you can choose the appropriate statistical tool for your research. For example, if your data is normal, then you can go for the parametric test. And if your data is not normal, you're not eligible for parametric test, you have to go for the non-parametric test in your research. Now you can see in this slide that you are working in a laboratory and you have collected a data. Clear? Might be either in the Excel sheet, or you can use a different software. So one software I'm going to introduce you today, that is called SPSS. We used to call Statistical Package of social science. Clear? Like, SPSS is the software which is widely used in the research, and it has been made by a company called IBM. So once we will carry out a research, we have to use some statistical tool like SPSS. We will enter the data in the software. So after entering the data, how to find out that we are ready for the analysis? Clear? And for that also, you have to check the normality distribution. For example, whenever you are conducting a study on the human beings or you are conducting a study on the animals, you have to calculate the sample size called as small n for your study, and assume that sample size of your study is 100. So after working on 100 animals, are you ready for the analysis or not? How to find out? And for that purpose, again we are using a test for the normality distribution. So test for the normality distribution will not have only single significance, it has multiple significance in the research. First of all, it will let you know that your data is normal or not normal. If normal, then you can go for mean and SD, and if not normal, you have to go for the median and interquartile range. The first significance of test for the normality distribution. The second significance is what? It will let you know that you are ready for the analysis or not. That it means that if you have calculated the sample size of your study, which was found to be 100, so 100 animals are sufficient to conclude, or you require a more number of animals to carry out the same research. So this you can find out after applying the test for the normality distribution. So that is the second significance. And the third significance, which is most important, after applying the test for the normality distribution, you will have an answer that either you have to go for the parametric test or you have to go for the non-parametric test. In statistics, we have a multiple test. For example, if you're going to see the B Farm syllabus 8th semester, or you're going to see the M Farm third semester syllabus, you are going to find that syllabus is also classified into two different sections. The first section is your parametric test, and second section where all tests are mentioned is called non-parametric test. So which test is more appropriate for your study? The answer of this question you are going to get after applying another statistical test called test for the normality distribution. Clear? So test for the normality distribution will give us result into uh, two types. That means either we are getting a bell-shaped curve, or either we are getting a skewness in our data, either negative or either positive. So whenever we are getting a bell-shaped curve, it means our data is normal and we are eligible for the parametric test. Clear? And if we are finding a skewness, for example, this is the shape of negative skewness and this is the shape of positive skewness. So having a skewness in your data is representing to not normally distributed data, apply the non-parametric test. So most of my student, they used to ask me always that either bell-shaped curve is necessary. For example, if you want to conduct a good research, so it is not necessary. Rule of stat says that after completing the sample size of your study, for example, you are performing a study and for that study sample size was found to be 100. So after working on 100 animals, either you are ready for the analysis or not. How to find out? You will go for the test for the normality distribution. Test for the normality distribution will give the result either bell-shaped curve, or it will show the skewness in the data. So if you have got a bell-shaped curve, it means 100 animals are sufficient to conclude your research. That means you are able to prove that A is causing B, or in your data you didn't get bell-shaped curve. So rule of the stat says you have to increase the sample size of your
Amit sir, you're not audible. Amit sir, hello. Amit sir,
Madam, again you call me. Sadhna madam.
Hello. Yeah, I don't know what's the issue, why it's getting disconnected again and again. Okay, let me share again. Sorry for the inconveniences made. Is shared slide?
Yes, sir.
Yes. So I was discussing that what is the role of test for the normality distribution. So what I said that if you have chosen that your sample size is 100 and you have completed your work on that 100 animals, so to find out that either you are ready for the analysis or not, you have to go for the test for the normality distribution. So test for the normality distribution will let you know that either these 100 animals are sufficient to conclude your research or you have to increase the sample size. Clear? Rule of stat says that you have to increase your sample size until unless you will not get a bell-shaped curve. Clear? So bell-shaped curve is necessary, but for the time-bound studies where you don't have time to increase the sample size, still you can work with the not normally distributed data, but statistical tool will be different. So test for the normality distribution will help you to choose the appropriate statistical test. That means you have to go for the parametric test or you have to go for the non-parametric test. So one rule you can keep in your mind that whenever you have received a bell-shaped curve, you can go for the parametric test. And if due to any reason you are not finding a bell-shaped curve, you can go for the non-parametric test. So this is the way like how we used to choose the statistical test. With the help of SPSS, even you can do this particular test for the normality distribution with the help of MS Office Excel also. But this screenshot which I'm going to show you is from the SPSS. These are the command which you're seeing right now, that point number 128. So I'll not let you know how to do it. I'll just show you in the pictures that this is the screenshot of SPSS software, and you can see that here I have added a age of the person. I will give the live demonstration of the software also, but here you can see that age of the patients. Here I am going to find out the normality distribution of the age. Clear? So age of the each patient has been entered. Like patient number one is having age 46, second 36, third 36, fourth 46, fifth is 36. Like this, you can enter the age of the patient in a single column. So these are the commands. You can go to analyze, and as you will go to analyze, you are going to get another pop-up called descriptive statistics. Clear? So once you click on descriptive statistics, new pop-up will come, and here you have to remember that you're not going to find a term called normality test or test for the normality distribution. Explore is the command which is used to find out the normality, or to check either your data is normal or not normal. So as you will click on the explore, this is the explore window, and here you can see that these are my variables for my study. Few are independent variable and few are dependent variable. So with the icons, you can identify that data of that particular variable belongs to what type. So might be you're going to see the different color sign. One, you have a yellow color sign and having a icon of scale. So that scale is representing to numerical data having a unit along with that. That means, for example, weight is having a unit called kg, height having a unit of centimeter, like this. Clear? And one more, you are going to get sign called three dots having a different color. So this sign is representing to categorical data. That means data is uh, represented in terms of category, like gender is having a two different category, male and the female. Clear? So as you can see that we want to check the normality of age. So what we have to do, we have to switch the variable into dependent list box. From this side we have to take the age into dependent list box. Already I have moved the variable, and you can see that age we have right now here. Clear? So once you will move the age, you have to click on the statistics. Clear? Under the statistics you have to check that what is the confidence interval of the study, and this is the another topic. For example, why we used to take always 95% as a confidence interval. So I just let you know one thing, that whenever we are carried out a research, we have to keep a margin for the error. So here we are assuming that in our research might be error will be 5%, and 95% we are assured about our hypothesis or about our work. So assurance you are giving in terms of number. So most of the statistical software will take confidence interval of the study by default 95%. But I did my PhD at a confidence interval of 97%. So it means what? If I'm taking a confidence interval of 97%, it means chances for error in my research was 3%. So higher the confidence interval of the study, your study will have a more impact in the society. Clear? So just check that confidence interval is 95 or not. Most of the academic research will be carried out at a confidence interval of 95% only. So you don't have to change. The software will keep it 95 only. And after that, you can go to plot. So plot option will give you that what type of plot you want to create. So you can click on the histogram and the normality plot. So two things you have to check here. The first, you have to click on the histogram, and second, you have to click on the normality plot. That means how the result of test for the normality distribution will be explained. And after that, you can click OK. So once you click OK, you are going to get the results. That means everything about the age. And you can see on the slide that we have got the mean, we have got the median, we have got the standard deviation, we have got the minimum, maximum, range, IQR, the value of skewness, and value of kurtosis. So this is the other description about age of the animal or age of the patient. So how the results will be written, you can see that how I've written the result here shows that the mean age was found to be 37.6, and 7.6 is the standard deviation. And on the same way, if you want to quote median, then you can write 37.5 is the median and 10 is the interquartile range. From here I have taken. Clear? So both things you cannot write in a single paper or single thesis. Either you have to go for the mean or either you have to go for the median. So what to write? As I told you, most of the researcher, what they used to do, they used to refer some others research paper, and if that author has written mean, we also used to write the mean. So it is not the way. We have to see what our data is representing. For example, this test for the normality distribution was started by two well-known scientists called Kolmogorov and Shiprovic, two scientists who have developed this particular test called test for the normality distribution. Standard for this particular test is that Kolmogorov value or Shiprovic value should be more than 0.05. For this particular test, we are taking more than 0.05. Otherwise, for all other statistical tests, we will consider a significant value opposite of this, that is less than 0.05. But for this particular test, we'll take more than that. So you can see in the circle that as per Kolmogorov, our value is more than 0.05 here also. And here also. So we can assume that our data is normal as per Kolmogorov or as per Shiprovilk. Now, when to use Kolmogorov and when to use uh, Shiprovilk value? For example, whenever your sample size is 50 to 2000, then you can go for Shiprovilk. And if your sample size is more than 2000, then you have to go for the Kolmogorov. But if your sample size is between 1 to 49, then both of these tests are not going to solve your problem. You have to evaluate your results by using the graphs. Clear? So two plots we are going to get. One we used to call QQ plot, and you can see a straight line. If all the data points are closer to a diagonal line, it is representing that your data is normal. Clear? And this is the equation we used to call Z test. Manually also you can calculate that your Z score is on the higher side or on the lower side. But for to evaluate that, we require a Z distribution table. So that is another method. But with the help of softwares, how we can find out? So one method is by seeing the QQ plot, and second method is by seeing the histogram. And you can see this histogram that we have got a bell-shaped curve. If we are getting a bell-shaped curve like this, we used to consider that our data is normal. Clear? And I'll show you another picture where we have a skewness in our data, and you can see this will be considered as a not normally distributed data. And picture on right hand side, this one is not normal, and this one will be considered as a normal data. So whenever we are getting a bell-shaped curve, it means our data is normal and we are eligible to write our result in terms of mean and SD. And if you want to apply any statistical test, for example, I want to compare age with fasting blood sugar or age with some other variable, I'll go for the for this case. But for this case, I'm not eligible for the mean, and the test which I have to apply to compare age with some other variable, then the test will be called as non-parametric test. So this is the way that how we are going to choose that we have to go for the parametric test or we have to go for the non-parametric test. So by applying test for the normality distribution, we can find out either we are on the normal side or we are having a skewness in our data. Clear? So that was the first. So once we have the answer for our question that our data is normal or not normal, we can proceed with our research. For example, you can see the first column that data is normally distributed. We can proceed with the analysis by applying the statistical test, which are under the parametric category. So these are the example that correlation, linear regression, paired sample t-test, independent sample t-test, ANOVA, ANCOVA, GLM. These all are the parametric test. These all are parametric test this side, and chi-square is the non-parametric test. Clear? So I have written that parametric test we can apply for two major cases, either for the time bound studies, first example, and second, whenever you have a skewness in your data, that your data is not normal, you didn't get the bell-shaped curve. So you can proceed for the non-parametric test. Now, the main thing, how to choose that which statistical test is appropriate for for our research. So for that, you should have an idea that what is your independent variable and what is your dependent variable. I'll let you know. I have given one example to you at the beginning that A is causing B. So A will be considered as independent variable and B will be considered as dependent variable for your study. Clear? And you can see on the chart, when you don't have independent variable and you have only dependent variable, and that dependent variable is given in terms of number, that is numeric data. And whenever I have written normal or not normal, it means the result of the test for the normality distribution. That means you have only dependent variable and that dependent variable is normal. You can go for one sample t-test. That means here you have got a bell-shaped curve and here you didn't get the bell-shaped curve. So test is going to change. That time test will be your Wilcoxon signed rank test. Clear? So this is the method you have to follow, the different algorithms, different tables to choose the appropriate. The main thing which you should remember is the basics. That means by keeping an idea in your mind that, okay, this is my independent variable, it belongs to what? Either numeric or either category. This is my dependent variable, it belongs to what? Numerical variable or categorical. And if numerical, then what is the distribution? Normal or not normal? Whenever you will have the answer of these four questions in your mind, you are able to choose the appropriate statistical test by referring these kind of tables. For example, I'll show another table to you. Now you can see in this table, multiple test has been written. You don't have to worry. You can keep that these are A, that means independent variable. These all are independent variable. And this is your B, which will be considered as dependent variable. Clear? For your study. And you want to build a relationship that A is causing B. Clear? Now, if A is categorical, B is also categorical, then the test is chi-square. Now, what is the example? Example is you want to compare gender with the location. Location means you have multiple districts, for example, or multiple states. You want to find out either male belongs to what state or females belongs to uh, what states. Clear? So one variable is states of India and second variable is the gender. Both side we have categorical variable. Under the gender we have two category, male and female, and under the states we have 26 or 27 states in India. Clear? So both side we have a categorical data. So test will be chi-square. Second example we have this one. If your independent variable is numeric, for example, numeric variable is age and second variable is categorical, your dependent variable is categorical. We'll take example as a gender. So test will be independent sample t-test. What it means, you can compare age with the gender. That either the age of male is on the higher side or female is on the higher side. Clear? For that you can go for the independent sample t-test. But on the same condition, the test is going to change if distribution is going to change. For example, if age is normally distributed, then the test is independent sample t-test. And if age is not normally distributed, then the test is Mann-Whitney U-test. So these both are the test, independent sample t-test and Mann-Whitney U-test, which can be applied on the same type of data, but result of test for the normality distribution is going to make change. Either you'll go for the independent or either you'll go for the Mann-Whitney U. So small things is going to lead you in the change in the different statistical test. So basic about your data, that means your data belongs to what type, either it's numeric or category. If numeric, then what is the distribution? It is normal or not normal? And on second hand side, if it is categorical, then how many categories are there? For example, under the gender, we have two category. And if I am talking about states, we have 26 or 27 states. And if you are going to give some option to choose, for example, you are doing a survey, and in that survey, you have keep a 5 different options that how was the class. For example, after finishing this particular class, I am going to take a survey from the student that how did you like the class. So options will be 4 or 5: poor, good, excellent, satisfactory. So 4 options will be there. So how many options or how many categories are there, based upon that the test is also going to change. Whenever you have 2 category, you are stick to a independent sample test. Whenever categories are more than 2, the test will be called ANOVA. Clear? Test will be called ANOVA. So whenever the category is more than 2, the test is called one way ANOVA. So like this, this kind of different algorithm or different charts you have to use. But you have to keep one thing in your mind, that my data belongs to what. So if you have answer for that, you are going to choose a appropriate statistical test. And more detailed videos about how to choose appropriate statistical test, you can find out in my YouTube channel called as Dr. Amit Sharma Statistics Made Easy. If you search on the YouTube, you are going to find there I have made a lecture series of different statistical tests. For example, you want to apply one way ANOVA through SPSS. So what are the requirements? How you are going to fill the data in a sheet? Then once the test has, how to apply the test, and once test has been applied, how to write the results of that particular test. Because with the SPSS, if you are going to apply one way ANOVA, the software is going to create more than 10 tables, but all the 10 tables are not required. For example, if you're writing thesis, then writing style is different, and if you're writing a research paper, then writing style is different. So based upon thesis, I have recommended that what to be included or what not to be included, or what you can exclude from the research or from the result part. So based upon either a writing of a thesis or writing of a research paper, you can refer those videos and you'll get a more detail or more depth in a particular topic. So this was the method that how we used to choose the appropriate statistical test for our research. So what I'll do, I'll encourage you to read further. There are different tables, guidelines, graphics, or algorithms are available on the internet, but make sure that you will be following a genuine source. Clear? So the tables which I've shown you, these 3 tables I have taken from the very well-known journal called Nature. So they have mentioned these tables in their author's guidelines. Okay, if you go to the ju- journal called Nature, and under that there will be a author's guidelines. There they have mentioned that if you are going to apply any statistical test, so your data belongs to what type. So these guidelines were given by Nature. So this video you can use, and I'll just let you know that all the statistical test is going to end up with a single figure. We used to call it a p-value. For example, I have applied a statistical test. I'm going to find a difference that, or I'm going to build a relationship between A with B. Finally, how A is correlated with B and how much correlation is there. So answer of these we are going to get in terms of figure, in terms of number. So those values are different. But statistical tests always they are going to end up with a one single value we used to call as p value. So what was the decision rule? This is based upon the confidence interval of your study which you have taken while applying the statistical test. For example, when I have applied test for the normality distribution, I have shown you that confidence interval that time was 95%. So cutoff point for that particular test is 0.05. Clear? Like all the statistical tests will have a this standard. That means cutoff point 0.05. So if your p value is less than 0.05, it means you have proven that A is causing B, or smoking is causing a cancer. If your p value is more than this 0.05, it means you were not able to prove your test result was not significant. Clear? So this p value or cutoff will be decided as per your confidence interval. If you're taking confidence interval of 95%, then cutoff is 0.05. And if suppose confidence interval you have taken 97, then cutoff point will be 0.03. So in that case, your p-value should be less than 0.03 to prove that your results are significant and to reject the null hypothesis. So always researcher choose the confidence interval of their study based upon their own hypothesis. But as I told you, most of the academic research will be carried out at a confidence interval of 95. Higher the confidence interval of the study will have a more impact in the society. Or we used to call that researcher is better as compared to next one or another one. So this was about the p-value, and I'll take I'll just show you the demonstration of SPSS software to you so that you're able to see. See, this is the overall layout of SPSS software, and you can see that a lot of data has been entered. So I'll just let you know from the beginning that how it looked like whenever you will open the software. I have opened a new file. Just give me a minute.
Okay.
Just give me a minute. Let me open. I have to save. Just wait. See, I don't want to show this file to you where all the data has been entered, because you will not able to understand how to enter and how to proceed with the software. So it's better to open a new file from the beginning so that you will be able to understand how to log in with the software as well as how to proceed. Just give me a second. Just give me a second. Just wait, it will open. Already few files has been opened, so it is taking time. Five, and you can install in MS Office as well as in MacBook. It is available in both the platforms. And if you're using a version less than 16, then you don't have to pay. It is available free of cost. I think the same file has been opened. Just wait. Yeah, you can see this is the new file. So whenever you will open the software, it look blank. That means you don't have anything. It's somehow similar to MS Office Excel. But at the bottom, you're going to find two different views. Currently, we are seeing a data view, and at the bottom, you have a variable view. So data view is used to enter the data. Okay, whenever you have planned your research and after doing the experiment, you are ready to enter the data. And variable view is used to customize your software, because the software is blank. Whenever you will open the software in your system, it's somehow like Excel sheet only and it's blank. You have to modify the software as per the requirement of your research work. For example, that how many variables you are having, so you have to create each variable. So variable view is used to make in sheet, and data view is used to enter the data. So first we'll go to variable view, and variable view you can see that few things has been mentioned on the top, that name, type, width, decimal, label, value, missing, colon, align, measure, role. So if you are familiar with these, that what to enter and each option belongs to what, then you are able to operate the SPSS. Otherwise it is very difficult. So I'll just let you know, in the name you have to write the name of the variable. For example, I'm writing age, that age is my first variable, and second is gender is my second variable, and third variable is, for example, dose of the drug, and fourth one I'll take another one more variable, for example, time. So four variable I have created. Now you can see that age, gender, dose, and time. And if I'll switch to data view, so all four I'm finding here on the top, that each column belongs to one variable. And if you are making in variable in the variable view, so each row represents to one variable. Clear? Second option is the type. So once you click on the type, you're going to get this menu bar, that age belongs to what. We know that age is a numeric variable, so we'll keep it numeric. But gender is not a numeric variable. Gender is a categorical, because under gender we have two categories. One is male and second is female. So we have to go to option called string. That string is the option which we will use for the gender. Dose is a numeric variable because we want to enter like 5 ml, 5 mg, 10 ml or 10 mg. So we'll keep it numeric. But time obviously is the date. So we'll choose the date or time, something. Clear? So width is not that much important. Width is that how much space you require. For example, you require this much space, or you require how much space is required to enter the data of that variable. So width belongs to that. After the width, you have decimal. For example, age, we want to write in terms of weeks. For example, I want to enter the data like this, 4.3 or 6.2. So after decimal, here I'm getting two digits because here it's written two. So if you are don't require, you can keep it zero, or you can keep that after how many decimal you require a digit. So based upon that, you can choose from here. Label is very important. Whatever you are going to write on the label, that will be represented on the answer sheets or the output sheets, because whenever you will apply the statistical test, the software is going to make a graphs for you, software is going to make a table for you. So what is the title of the study, what is the title of that graph, what is written on the bottom of that graph will be written by the software, what you are going to write in the labels. So, and whenever you are giving a name to a variable, don't write more than 8 characters. That is the rule. In SPSS, the name of the variable should not be more than 8 characters. For example, I have to write a systolic blood pressure, so I'll write SBP only. And here under the label, I'll write the full form of SBP, that systolic blood pressure. And on the age, we can write age of the animal. This is, for example, if you want to, you are going to send your sheet to some other person or some other researcher, they should able to find out that what is the meaning of SBP or what is the meaning of the coding. Or you can write gender of the animal. like this you can click. Clear? Now next one is values. This is also important. For numeric variable we don't have to keep any values. Value means we are giving a code store data. Under the gender we have two category, one is male and second is female. So one will be given to male, lad, and two will be given to female, lad. Here, so like this coding will be done. For example, if you're giving a dose, so manually you can write that what dose has been given to the animal, or you want to convert your dose variable into different categories. So you can change like this also, like 1 means 5 ml, okay? Or 2 means 10 ml, or 3 means 15 ml, like this you can add. So now those will become the categorical variable. As I have given the labels, see software has not taken because here it is numeric. Under the type it is numeric. So if you want to give a coding to your dose, then you have to change this one into a string. Then you can give that 1 means 5 ml, 2 means 10 ml. So for example, if you are making a variable drugs, that which drug has been prescribed. So you can keep 1 means beta blocker, 2 means calcium channel blocker, 3 means diuretics, like this you can add. Clear? Next variable is your missing. See, it is not necessary that we are going to get the data of all the variables. Sometime data will be missing. So that time this missing command will be added, and in SPSS community all the missing value will be represented as 999. For example, if I'll go to data view and I don't know that what dose has been given to this patient or animal number 1, so I will write here 999. This 999 will be represented as a missing value. So what will happen, whenever you will do the statistical analysis, the remaining variable will be considered as 100%, and that 999 variable will be considered as a missing value that will not be added into the final statistical analysis. So first you will keep all the column blank. That means you didn't get the data of this column or you didn't get the data of this column. You will keep this column blank, and once you have customized your whole sheet, that means data of your whole research has been added into a sheet, that time you can add the missing command. For example, if age of some animals are missing, you don't know, so that time you will add the command missing value in terms of 999. Clear? If you know the gender of all the animals, then no need to add the missing value. Otherwise you can add the missing value here. Column is not that much important. Align, this one is very very important. And the last one, measure. That means age belongs to what? Three options will be given by software: scale, ordinal, and nominal. Now, scale variable I cannot choose because scale variable will be used for a numerical data, but having a measurement unit along with that. For example, height, centimeter, weight. Weight we can measure in terms of mg, in terms of kg. That is the measurement unit. Length we can measure in terms of centimeter or kilometer, like this. Clear? So wherever you will have a measurement unit, for those variable you can choose scale. Age is a having a unit, but that unit is years, and years is not a measurement unit, so we will choose the ordinal. So whenever your data is given in terms of number, so you will have a two options, either go for ordinal or either go for scale. But scale you can choose for those variable where you have some sort of measurement unit along with that. For example, we have a systolic blood pressure. So obviously we can measure the systolic blood pressure in terms of mmHg. So to systolic blood pressure, I will keep this one as a scale. Time is ordinal because these are just numbers. Dose, we have made the category. So all the variable wherever you have made the category, for example, we have made the category under gender and dose, so they will be considered as nominal. Clear? And the last one is drugs. Drugs is also categorical, so categorical will be considered as a uh, nominal data. So three options you are having. I'll just remind again. You will have an option of scale, ordinal, and nominal. Scale will be used for numerical data, but measurement unit along with that. Ordinal is also used for numerical data, but does not contain measurement unit. And nominal is used for the data which is having a multiple categories. And the last option is the role. That what is the role of age in your project? It is independent variable, it is dependent variable, or both. So most of the variable which is going to represent your population will consider as an independent variable, and all the lab values will be considered as a dependent variable. For example, here dose will be considered as input, whereas systolic blood pressure will consider as target. Drugs will be considered as input. Time will be considered as input, obviously. And dose will be considered as input. So you have to think in such a way that that variable belongs to what? Independent variable in software, it is taking as input, and dependent variable will be considered as target. So like this, once you will customize your sheet, you will add all the variables, then you are ready for the entering the data. And you can see I will not write male, I will enter one and I will enter two. So as I will enter two, it will take female. So data of gender will be added in terms of 1 2 1 2 1 2 2 1 like this. I'll just write 1 1 1. Obviously, it is going to convert into male female male female. Those also we made the category. We have drop down menu. Either two category we have made 5 ml and 10 ml. So we can choose that either which, or directly you can enter the code, and codes will be written can be seen from this option which is given on the top, that a and 1. You can see I'm changing right now from this option a and 1 on the top. So like this you can enter the data. Just enter few things. Now you can see now if I'll discuss about patient number or animal number 3. So animal number 3 is having a age of 2 weeks. It's a male. Dose is given 10 ml. Time I have not mentioned. His blood pressure systolic was found 135 after giving the dose, and he was treated with a drug called diuretics. Clear? So like this you can make the sheet. And to apply all statistical tests, you have to go to option called analyze, and the same test I'll let you know that which we have applied test for the normality distribution. We'll go to explore command, and you can see that we have a age of the patient. So animal whatever, we'll add age in the dependent list box. We'll go to statistics, it's showing 95%. Okay, we'll go to plot, we'll click on histogram and normality plot, we click continue and okay. So we are going to get the results of uh, age of the animal. See, everything we have got: mean, median, standard deviation, minimum, maximum range, interquartile range, and all. And Kolmogorov reading, you can see Kolmogorov and Shiprovel says that data is normal because both p-value, I have got this one and this one more than 0.05. But here with a only five number of patients, we cannot assume about the shape. But as per Shiprobil, I can quote in my results that my data is normal. And if I want to compare age with some other variable, I'm eligible for the parametric test. And now I'm eligible to write my result in terms of mean and standard deviation. Clear? So this is the way. And actually, I have another meeting at 3:30. So this is the way that how we are going to operate the software. So if any student is having a doubt, I'll happy to take the query and more detail about the software, how to apply each statistical test. You can go to my YouTube channel. There I have made a one lecture series of 15 days. So I'll recommend you to go for that, but don't go to day 10 or day 11, day 12 at the beginning. Start with the day 1, and that is a short-term course on biostatistics and research methodology. Basically, that course we used to sell for the 10,000 rupees. I'll recommend you to go for that free of cost through my YouTube channel. You don't have to pay. You'll get the same knowledge whatever we used to give in the short-term course in free of cost for you guys. So start from day one. You will be able to see that how to make an SPSS sheet. And after, as you will proceed to day 6, 7, or 8, you will be able to operate the software actually, and you will be able to apply any sort of statistical test which is there in your syllabus, or everything has been described in detail, that after getting a result, for example, this shortcuts can be used to create the graph or to create the data. And if we are getting a 5 or 6 tables, so out of these 5 or 6 table, which is more necessary for the research point of view, which data can be added into the thesis, which data is more important for the research paper point of view, all these things you can get on those videos. Just go to that. And if you have any query, my number is with the ma'am, as well as it is given on the YouTube channel. You can WhatsApp me, you can give a call to me anytime. I'll be happy to take any queries, no issue. Clear?
Yes,
Because
students.
because shortage of time, I have to take another meeting. So more detail about
Okay.
the topics will take some other day. Huh?
Okay, sir. Yeah, all right, sir.
Okay, okay, take care.
If student have an query, just couple of queries, they
Yes,
will
yes,
ask because sir,
yes.
sir have a busy schedule, so that's why. Yes, anybody have a query?
Am I audible?
Yes, students.
Hello? Am I audible?
Yes,
Yes,
sir. Yeah,
yes.
you are audible, sir. Yeah.
So just I have one query, or I can say just I want to elaborate. I can say I'll tell you to elaborate on F value. How you just elaborate that term F value. It is reported always in
P, P value you're talking about.
P is there and F is also there. No, in bracket they will give some F in bracket likewise. P is less than or less than
Yes.
0.5 like when they report. But what is that F value?
Yeah, see, F value is, yeah, I'll let you know. F value is representing to test called one-way ANOVA. Okay. One-way ANOVA is representing to F value. And if I show the presentation to you, you will be able to understand that what is the meaning of F. Just wait, I'll just show you. F is the sign which is commonly used for test called one-way ANOVA.
Degree
Okay.
of freedom.
Pardon?
Is it degree of freedom or what?
No, degree of freedom is the another thing. Okay, degree of freedom is not the F value. F is the sign which we are using for one-way ANOVA. And if I show the sign to you, just wait. I'll show. Okay, what is the meaning of F exactly? Yeah, if you'll see the hypothesis, yeah, this is the F value. Might be you're able to see. Clear? This is the F, and this is representing to ANOVA. Okay, what is the final value of ANOVA? कि F is equal to MST divided by MSB. That is mean of sum of square divided by between and treatment. But degree of freedom always for ANOVA will take n minus 1. That is, if your sample size is 150, so degree of freedom, if you have applied one way ANOVA, will be 149. If you have applied student t-test, then 149. Degree of freedom value will be something else that is representing that which test you have applied. And I'll just show what is the meaning of that exact F view. Here you can see, F means this one. Are you able to see this? F stands for ANOVA coefficient MSD divided by MSC. See, this you are not able to understand like this. For that, you have to take a whole lecture on one way ANOVA. So either you can give a call to me, I'll let you know, or you can watch the video. Then you are able to find out that what is the meaning of exact F.
Yes, sir. Yes, sir. We'll try to keep one session on this, ANOVA, especially ANOVA.
Yeah, I'll take within 1 or 2 days if time permits. If your principal sir or your ma'am is allow me to take a session, I'll take no issue.
Yes, sir. Yes, sir. I know that it's not 1 hour, we can say task. It is required so much, I can say hours to see
Yeah,
this.
ANOVA is a very well-known test which is used by most of the researchers.
Yes.
Right?
Yes, sir. Thank you, sir.
Okay, okay. So take care.
Yes, sir.
Okay, thank you, ma'am. I have to take a
Yeah.
join the meeting. So take care.
Yes, sir. Thank you, Amit sir, for this wonderful session. You took a demonstrative session, so student easily understood all the terms. Definitely, your session will be helpful to all the informed students in their research work, and they will give their excellence in their work with the help of statistical tools. So, student also, if suppose they have any doubt regarding with the statistical methods or the tools, you can refer the YouTube channel of Amit sir. Okay, so thank you very much, sir. I will call you later after your meeting, sir. Thank you very much. Yes, Amit, sir. Hello, Amit, sir. Okay, we will end the session right now. Student.
I think he left, ma'am. So,
Yeah,
we can
yeah. Okay, yeah. I will conclude the session over here.